Hey folks, Caleb with Auman Landscape here on the Auman Landscape YouTube channel. We're here talking top, I was gonna say top 3, but I keep thinking of all of them that I want. Top retaining wall tips. When you're building retaining walls, considering building retaining walls, whatever. And we talk about this 2.5 hours in depth at thehardscapeacademy.com in our how to build and how to install retaining walls training course. It's actually this wall here that we built, so you can see the guts of this thing and how we actually build it. But I'm gonna give you the top 3 or 5 tips. We'll see how it goes. This is not in any one particular order because they're all integral to how a retaining wall performs long term. So I'm going to start just with number 1. First tip is make sure that, and you won't be able to see here, embedment. That is a big deal. We want to make sure that we have a course of block minimum buried. So we'll dig down here and you'll see that we have a course of block below grade here. There we go, right there, see? So there's a course of block below grade. What that does is that helps with stability of this project. A couple things. It's kind of like my foot sitting on top of this slope here. But if we were to, for my foot being on top here, it can slide right off. But if we were to dig a hole and bury my foot, it's gonna be more locked into the ground. The same thing, it's that same principle with retaining walls, right? So block embedment is the first tip, not the number 1 tip, but the first tip. It's 10% of the overall wall height or a minimum of 6 inches. So this is 6-inch Unilock block. Big thanks to Unilock for supplying material on this demonstration, if you will, for the Hardscape Academy. Second tip is your base construction. So we want to build on a good solid base. We use, in most cases now, a number 57 angular limestone here. And this is what we'll actually dig that out, compact your subsoils, and set it on about 6 inches of this number 57 angular, because that is the angular aspect of it is what it locks. If it were round, of course, it would roll in my hands forever. So we use that. You could also use a dense graded base, which is fine. And there's actually some applications for that, but it's gonna be like this, where you've got the fines in there and it needs compaction force. Again, a 2.5 hour long video on that. But that's sitting on top of that. Followed by, as we build the wall up, we want to make sure we have our wall block offset each course. We don't want to ever vertically stack the block. This gives it more strength, whatever. Then we're going to backfill a minimum of 12 inches back behind the wall. This is another biggie. This is like one of the top number 1 things here is drainage aggregate behind your wall. So about 12-inch profile back minimum, the more the merrier, frankly, of, again, number 57 clean stone, because water passes through it, it does not sit in it. So we're gonna have that in there, backfilling the wall. And this goes for any wall, timbers, segmental, formed and poured concrete walls, whatever it is, you want drainage aggregate behind there. That's a big freaking deal, folks. That water adds weight to the wall. It lubricates the soil also, so it's more prone to just moving and sliding. And also the freeze-thaw expansion of it in the wintertime. So those are, that's a big deal there. Okay, so where are we talking? We've got our embedment, we're talking our block staggering, our offset of bond, and our drainage aggregate behind it. Another thing is water management behind the wall, especially when we're on a big hill like this. Ideally, the ideal thing to do is to cut a swale behind your wall. You don't want to run the water right to the back of the wall. That's not the ideal thing to do. But in this case, and anytime you can, we want to cut this back and create water, cause water to go from the wall, from behind the wall to a swale area, and the water come down off the hill to a swale area that would wash around the side. This wall we intentionally built this way to show what it looks like if you don't do a turn back into the hillside. And even though we've wrapped it with this non-woven geotextile fabric, that soil is actually held pretty decent, but it's not going to be acceptable really. And then in this side of it here, we did, for example's sake, a turn back into the hillside here, where it helps envelop and allows you to hit that grade and wrap around like that. So we wanted to show both of those in that course and what that looks like when you build along a wall here and how you handle the slope each side. We also talk about stair stepping into there and all that kind of stuff. We talk geogrids. This is edging for paver installs. And this is, well, I'll show you this real quick. This is, I swear, I think we're like some of the first people, if not the first person to do this. But we would take geogrid, lay it under, this is on paver installations, mind you. But we'd take geogrid, and this is a a uniaxial, which we talk about this in Hardscape Academy and the training videos for retaining walls. This is a uniaxial strength, and so it's got strength going only this way, right? And biaxial is the strength another direction. But we would take our base, and we'd lay this geogrid out there, and then we'd put in a setting bed of 1 inch of number 9 limestone, which is kind of like the smaller stuff there, not screenings or any of that crap. And then we would lay our pavers, and then we take that geogrid and we pull it back, and we'd pack some concrete edge restraint. I think this is actually perm edge, but you know, any concrete edging, any concrete product really will do. And we'd pack some of this concrete up under it. Then we'd lay the fabric back down and put some concrete on top of it. And then you've got this crazy, you know, all the block pushing down on here, pulling and sucking that edging in. And I believe it to be a really strong, I mean, look at that, it's cracked, but the geogrid's holding it together, as well as that fiber. So that fiber's a great thing to have in there. But you know, your pavers are actually gonna sit about up that high. This is a bit overkill on the amount of concrete you would normally use. I digress. Retaining walls, okay. So now we've got drainage aggregate. Another thing to consider too, and this is a policy of ours, and we talk about this in a video for this one, is your evacuation of water that will potentially or does potentially get behind your wall. It's got to get out of here. And so we're going to have a pipe in behind here, a perforated drain pipe that will pick up water at the lowest point back in there. And we've dug a trench, and that pipe runs out over the hill here. So you've got to kind of make sure that you've got a way to drain water out, or even get it out to here to a weeper pit or something. That water's got to get the heck out of there. So we set a pipe in there, generally at the back of the excavation, with the slope go running to it, and the very lowest point of the project, and so it pulls the water out and takes it out. So that is a quick few minute video here on retaining wall installation, the basics, kind of the top tips, the top things you need to be watching, and then capstones too. Picking out a nice capstone. This is again a Unilock Pisa XL unit, and then I've got a paver brick or a clay paver collection here, and people will send these to me and from all over local, and this is some more Unilock sample product here. Another thing is actually height, and look, designing retaining walls is a big deal if it's going to be over 4 feet. Any retaining wall generally over 4 feet tall is going to need to have geogrid reinforcement. But caveat to that is, even a shorter wall, if it's under live or static load. Static load is like you know, an object sitting back here, a fuel tank, whatever. Live load is cars, people, moving traffic, whatever. That's live. Like a vehicle going through here is a live load. Until it's parked, then it's static load. But that's got to be designed around. So be sure to talk to a design professional, or you know, a retaining wall design professional, engineer, whatever, about how to lay geogrid into this thing so it can support that weight. Because even a 2 foot wall, 2 foot high wall, can be blown out by a vehicle sitting behind it. And retaining walls are no joke. You can end up in court over these things if they fail, potentially hurt people, whatever. So we've got to make sure. And we talk about in the you know, the install videos and all that stuff about, like, we don't tell you how much geogrid to use or when to use, or we tell you kind of when to use geogrid, but we talk about the basics of geogrid and how you do install it, because it's always a case-by-case basis. So we want to make sure we're paying attention to that. Other than that, folks, that's kind of really, I guess, the big part of it there. Good luck in your retaining wall construction. Check out the hardscapeacademy.com for more tips, and actually for a full-blown training course, 2.5 hours, on how to install retaining walls. Thanks, folks. We'll catch you on the next one. We'll see you. You know, when you actually meet somebody you really admire, you're generally let down. And in this case, that's totally wrong, because Mike Rowe is every bit as awesome as you hope him to be. And it was really cool to get to talk to him. And he is a phenomenal interviewer, because even off air, let's say, where we were killing time, because fortunately they were the ones having technical issues, not us. He's did a phenomenal job of coming across as he was interested in what we had to say or what we did and all that stuff. And they say a great communicator and a great spokesman, or, you know, great individual, the goal is to be interested, not interesting. And so Mike did a phenomenal job of acting like and maybe he was genuinely, I don't want to suppose that. But he did a phenomenal job of being interested in what we did as a company and how it pertained to, excavating practices and what we're doing there.